Welcome to one of the most misunderstood topics in all of science, the p-value. Whether you are reading a medical study about a new vaccine or a marketing report on consumer behavior, the p-value is the gatekeeper of truth. But what does it actually represent? Today, we will demystify this statistical concept and learn how to interpret it like a pro. To understand the p-value, we first need to meet its best friend, the null hypothesis, or H0. Imagine we are testing a new energy drink that claims to make people faster. The null hypothesis is the skeptical view. It assumes the drink does absolutely nothing. It posits that any difference we see in running speeds is just due to random chance, or noise. Now we perform an experiment. We measure the running times of a group that drank water and a group that drank the energy drink. We find that the energy drink group was on average 2 seconds faster. Is this statistically significant? This is where the p-value comes in. The formal definition of a p-value is the probability of observing a result at least as extreme as the one obtained, assuming that the null hypothesis is true. In simpler terms, if the drink is actually useless, how likely is it that we would see a 2-second difference just by pure luck? Let's look at the bell curve, or the normal distribution. This represents all possible outcomes if the null hypothesis is true. Most results fall in the middle, no difference. As we move to the edges, or the tails, the results become more extreme and less likely. The p-value is the area under this curve representing our result and anything even more extreme. Usually, scientists use a threshold called the significance level, denoted as alpha. The most common alpha is 0.05. If our p-value is less than 0.05, we say the result is statistically significant. This means there is less than a 5% chance that we would see such a result if the null hypothesis were true. We then reject the null hypothesis. However, there is a massive trap here. A p-value of 0.04 does not mean there is a 96% chance the energy drink works. It only tells us about the compatibility of our data with a boring world where nothing happened. It is a measure of surprise, not a measure of certainty about the alternative. Another common mistake is confusing statistical significance with practical significance. A study with 1 million people might find that a pill lowers blood pressure by 0.1% with a p-value of 0.0001. It is highly significant, but the effect is so tiny that it's useless in the real world. Always look at the effect size, not just the p-value. In recent years, the scientific community has faced a replication crisis. One reason is p-hacking. This happens when researchers run dozens of tests or manipulate data until something, anything, comes up with a p-value below 0.05. Remember, if you flip a coin long enough, eventually you will get 10 heads in a row, but that doesn't mean the coin is magic. To wrap up, the p-value is a powerful tool for filtering noise, but it's not a magic truth button. It must be used alongside confidence intervals, effect sizes, and most importantly, common sense. Next time you see a headline claiming a significant discovery, ask yourself, what was the null hypothesis, and is the effect actually meaningful?